How would you solve this? Maybe you can give it a try, maybe spend half hour or 1 hour trying to find a solution. But let me tell you that there is probably no way how to solve this using paper and a pencil. So how can we get a result of this? Today I'm going to present you the bisection method. This is an algorithm that finds the result between 2 points. For example, A and B. The only rule we have to follow is that the function evaluate in those points have to have opposite signs. Why? Because that means that between them there is gonna be at least one solution, in this case the red point. Now what we are going to do is to find the middle point, and we will call it x. When we evaluate x, if it has the same sign as A, we will replace A with x. Otherwise we will replace B. In this case, it was positive as A, so we replace A with X. And we do that again and again. We find X, this time is positive, so we replace A, but now this time X is negative, so we replace B with X. In that way, every time we are going to get closer and closer to the real result. So in order to code the bisection method, I'm going to use Python, but you can use any other programming language. I'm going to port math to use the e-value and also decimal to work with floats correctly. Why? Because, for example, if I do this operation in Python, I'm going to get 2.3, that it's correct. But if we know a bit of computers, we know that the real result we must to get using floats is something like this, that there is a little error, but this is the result we are going to get using C or Java and other languages. Well, you can use it or not, there shouldn't be a big difference. Now I create this function that only evaluates this function shown above in a point, in this case x. I parse x into the type of decimal and I return the value of the function in that point. Now I create the function bisection that needs 4 parameters, a, b, the number of iterations, and the tolerance. The tolerance is actually the error we are agreed to assume. If the tolerance is really little, really small, it means the error we are going to get is also really small. First of all, I did some verifications. The first verification is that the function evaluate in A multiplied by the function evaluate in B. If it is bigger than 0, we will return false. It means that there have to be a change of signs. Otherwise, there is an error. We are not going to find a point between them. That's the rule we have to follow. Also, what I did here is to evaluate the point A and B, and if they are already the result, I'm just return A and B with 0 iterations. Now I'm going to do a loop. For iteration in range, the number of iterations, I'm going to find x, that is the middle point of A and B. So A plus B by 2, it's going to be x of the type decimal. And if the function evaluate in x it's equal to 0, so we find the result. But also, if the distance between B and A is really close, really small, smaller than the tolerance, we can consider it also as a result. So then I return the float parts of x because x was a decimal, so I'm going to return a float, and also the number of the iteration we are now. If we didn't find the result, I'm going to replace B or A with X. So if there is a change of sign, I'm going to replace B. Otherwise, I'm going to replace A. And that's all. If I don't find a solution in this number of iterations with this tolerance we gave, so I'm going to return false. We didn't find the result. Now, if I run the code, we get this value. 0.25720 and so on with 13 iterations. If we go to the graphic, this is the graphic of the function, and I'm going to put the point, and we will see that if I zoom into it, it's really close to the real value, that is this one. This is the real value, and this is the result we got. It's really close. If just are some decimals of difference, but it's not the real result of the function. If we want to get closer to the real result of the function, the only thing we have to do is to change the tolerance to make it smaller. For example, this tolerance. Now I run the code and we get 25,753. That is this point. As you can see, it's now closer. But if I zoom again, it's not the real result, but it's really, really, really close. So if we make the tolerance smaller, we are going to get closer to the real result. If you don't understand what is tolerance yet, here I give an example. If the result we get is, for example, 2, and the tolerance is 0.01, it means that the real result is between 2.01 and 1.09. So we can be pretty sure that the result is between these points. If you want to evaluate a function in another function, just change this part of the code. The code would be in GitHub, and the link is gonna be in the description. And well, that's all. I hope you liked this video. I hope it was useful. I would really appreciate if you leave a like. And if you have some question or something you didn't understand, you can leave it in the comments. That's all for today. Thank you.